So in this video, we're going to talk about definite integrals. And it's this idea that we're now evaluating the integrals at a certain point. So looking at this first one, all right, the integral from 0 to 2 of x cubed dx. Well, again, the x to the n plus 1 divided by n plus 1 rule says that we could take this function here and say, well, this is x to the 3 plus 1 is 4 divided by 4. And this will be all evaluated from from 0 to 2, from 0 to 2. All right. Now I have my equal sign there. I have my kind of fraction bar here, my equal sign here. And now I could just plug in my numbers, right? So it's always the top number minus the bottom number. So I'm going to plug in 2 for x. All right, so this will be 2 to the fourth power divided by 4 minus 0 to the fourth power divided by 4. This goes to 0, right? So your answer is just here is just going to be 4, right? Because 2 to the fourth power is 16. 16 divided by 4 is just 4. This cancels out to be 0, so your answer is just 4. How about this one? The integral from 2 to 3 of 2x plus 2 dx. Well, again, taking the integral, I'm going to keep my constant of my 2. So this will be 2. This is x to the first power. So I'm going to add 1, which will be x squared divided by 2 plus 2x. And that is my integral evaluated from 2 to 3. And that's going to equal something that I could simplify better. All right, so this will just be the integral of x squared plus 2x integrated from 2 to 3, right? And now I could just plug in my numbers, do my numbers on the bottom end here. All right. I'm gonna have my equal sign. Be careful with notation, guys. You always want to put your equal sign after you have the fraction bar. All right. So this now will be 3 squared plus 2 times 3. Put this whole thing in parentheses. And I'm going to subtract this from 2 squared plus 2 times 2. All right, and now we could just evaluate. So 3 squared is 9, right? So this is 9 plus 2 times 3 is 6. All right, still in parentheses, minus 2 2's is 4, plus 2 times 4 is 4. So 2 squared is 4. 2 times 2 is also 4. All right, so this now becomes 9 plus 16. Well, that's 10. That's 15. All right, so now you have something like 15 minus 8. All right, and then 15 minus 8 is simply just 7. All right, so that should be your answer. How about this one? The integral of 0 to pi of sine of x dx. Well, again, the antiderivative of sine of x is just negative cosine of x. Negative cosine of x, and that will be integrated from 0 to pi. Now, again, for those of you who are wondering how I got this is right off the spot, well, again, think about it. The derivative of cosine of x is negative sine of x, right? However, we got to attach this negative here because a negative sine of x times a negative will give you positive sine of x. All right, so here's a trick, guys, with trigonometric functions. Whenever you take the antiderivative, take the derivative of the antiderivative and see if you actually got the original function that you started with, right? So when I take the derivative of cosine of x, I get negative sine of x, but I also have a negative here. My sine of x is positive, so this is the reason why I need a negative here. All right, so that was just a quick review. So the negative cosine of x integrated from 0 to pi, and now I could just plug in my values where I could say, well, negative cosine of pi, all right, minus negative cosine of 0. All right, and now trig comes in very important, right? So negative, well, cosine of pi is just negative 1. All right, I'm going to put my minus sign, which comes from here. All right, and then again, cosine of 0 is just 1. So this is negative 1. All right. So again, this turns out to be, okay, well, Negative times a negative is a positive, so this is just 1. Negative times a negative is a positive, so this is just 1 plus 1, which will be 2. Let's look at another one. The integral from 0 to pi of cosine of x dx. Well, the antiderivative of cosine of x is just sine of x, and that will be evaluated from 0 to pi equals sine, and now I could just plug in my values, right? So sine of pi minus sine of 0. All right. Well, sine of pi is just 0. Sine of 0 is just 0. So the integral would just be 0.